Welcome back. In this lesson, we are going to look to creating a networking environment, and we will understand the architecture need of the Café, and we will see how we can connect multiple AWS networking environment to the internet and how we can secure our AWS network. We will learn how to design a network in AWS and build a VPC with subnets, and you will also learn how to connect instances in your public and private subnet to the internet. The Café business has been steadily increasing. Sophia and Nikhil have become friends with a few of the Café regulars who are AWS consultants, and they have started to discuss the Café current architecture. Olivia, one of the regulars and an AWS solutions architect, identified a need for the Café's online business to scale. Scaling will require additional services to run the online ordering application, but the current subnet size is too small and cannot support this growth. Therefore, they will need to recreate some aspects of the network that the application runs in. On further review of the Café's architecture, Olivia also noticed a vulnerability. The TCP port that used to administer the application server is accessible to the internet. Sophia explained that she and Nikhil must be able to manage and maintain the server. Olivia advises them to set up a Bastion host to reduce public access to the server and to make it more secure. In this lesson, we will understand how to create a Bastion host, and we will use it to access our private EC2 instances in our private subnet. Now let us look to creating an AWS networking environment. Amazon VPC provides a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. Amazon VPC gives you control over your virtual networking resources. You can select your own IP address range, create subnets, and configure route tables and network gateways. You can use both IPv4 and IPv6 in your VPC for securing access to resources and application. You can also customize the network configuration for your VPC. For example, you can create a public subnet for your web servers that can access the public internet. You can place your backend systems such as databases or application servers in a private subnet with no public internet access. You can use multiple layers of security to help control access to Amazon EC2 instances in each subnet. These security layers include security groups and network access control lists, which we will understand in more details in this particular lesson. A VPC normally is associated with a single AWS region. This means that the VPC cannot span multiple regions. However, a VPC spans multiple availability zones in a single region, so it can host supported resources from any availability zone within the same region. When you create a VPC, you provide a set of private IP addresses that you want instances in your VPC to use. You specify this set of addresses as a CIDR block or a classless entire domain routing. So for example, if you give the IP address 10.0.0.0/16, this is the primary CIDR block of your VPC. This means you can assign a block size of /28, which is the smallest block size in Amazon VPCs, and the largest one is /16. Also, Amazon VPC support IPv4 and IPv6 and has different CIDR block size limits for each. All VPCs and subnet must have an IPv4 CIDR block. You can change this IP after the creation of your VPC. Amazon VPC can operate in a dual stack mode. Your resources can communicate over IPv4 or IPv6 or even using both IP protocols. The IPv4 and the IPv6 addresses are independent of each other, so you must configure routing and security in your VPC separately for IPv4 and IPv6. You can divide the VPC into one or more subnets. A subnet is a logical segment or a portion of your VPC IP address range where you can allocate a group of resources And it is important to remember that a subnet are not isolation boundaries around your application. Instead, they are a containers for routing policies, which you will learn about in the next section. When you create a subnet, you specify a CIDR block of the subnet, which is a subnet of the VPC CIDR block. Now remember, a subnet CIDR block cannot overlap. Each subnet must reside entirely within one availability zone, so each subnet should be associated with a single availability zone. Now, the same availability zone can have one or more subnets. You can optionally add subnets in a local zone. When you create a subnet in a local zone, the VPC is also extended to the local zone. Because VPC subnets are mapped to a specific availability zone, subnet placement is one way to ensure that your Amazon EC2 instances are distributed across multiple locations or they are multi-AZs deployed. AWS reserves the first 4 IP addresses and the last IP addresses in each subnet CIDR block. So for example, in a subnet with a CIDR block 10.0.0.0/24, AWS reserves 5 IP addresses. The first one, which is the 10.0.0.0, which is the network address, and we know this from the classical networking in a local area network, that we always need to reserve the broadcast address, which is 10.0.0.255, and the network address, which is 10.0.0.0. Now in AWS, they also reserve the 10.0.0.1, which is the first IP in the subnet, and this is for local router, which is the destination you configure when all these EC2 in the same VPC in different subnets they want to communicate. Also, we reserve 10.0.0.2 for the DNS, because every time you create an EC2 inside the subnet, it will get a public DNS and a private DNS, so we need a domain name system operate in that VPC. And the last one is 10.0.0.3, which used normally for future use. When you configure any computer network, you need to consider the universal networking design principle. Create one subnet per availability zone for each group of hosts that have a unique routing requirement, or a tier. Or maybe classify them based on the services that you have. For example, front-end, back-end, and so on. Divide your VPC network range evenly across all availability zones in a single region. Do not allocate all network addresses at once, and maybe create a size for your VPC that can accommodate a significant growth for the future. Ensure that your VPC network range does not overlap with your organization other private network address, specifically when you have a hybrid cloud and you have an on-premises data center where you have some private IPs used and they want to communicate with resources in the cloud. When you design and create your networking, there are a limited number of use cases where a single VPC might be appropriate. For example, when you have a small single applications managed by a small team, when you are looking for high-performance computing, or a single VPC environment that has lower latency than one spread across multiple VPCs. When you are dealing with identity management environment, a single VPC might provide best practices. For most use cases, a multi-VPC environment is required. You can create a multi-VPCs within the same region or in different regions, and you can also create multiple VPCs in the same AWS account or in a different AWS account. In the multi-VPC pattern, it's more suited when you have a single team or organization that maintains full control over the provisioning and the management of all resources in each application environment. For example, you have a team looking for production, a team looking for testing, and a team looking for dev. You can also create multiple VPCs in the same AWS account or in a different multiple accounts. Now, this is normally referred to as the multiple account patterns, which are more suited for enterprise customer or organizations that they have multiple teams spread around the globe. You consider an enterprise global company where they have, for example, a team in Ireland, a team in India, and a team in the United States. And each of those teams, they need kind of central control over their networking resources, and they want to have a full access as well with no limitation in their access. Be aware that Amazon VPC codes is 5 VPCs per region, and this is normally an exam question. Now, how we can connect your AWS networking environment to the internet? The first services that you need is the internet gateway, which can allow you a communication between the resources in your VPC and in the internet. Internet gateways are horizontally scaled, redundant, and highly available by default. They provide you with a target that you can use in your routing table, and once you connect a subnet to that target in the route table, that subnet will be considered as a public subnet. When you use a route table, you can associate it with a subnet that you want to connect to the internet, and a route table normally contains a set of rules. All these rules are called routes. Each route are basically used to control how the network traffic should be routed between your subnet and the targets. In general, the main route table is created by the creation of the VPC wizard, and it only contains a single local route which can enable the communication between all your resources inside your VPC. You cannot modify the local route in a route table. This is another exam question. When you launch an instance in the VPC, the local route automatically covers that instance. You don't need to add the new instance to a route table. You can create additional custom route tables for your VPC. And we will see later on, you might create multiple route tables for each availability zone to guarantee multi-AZ deployment and high level of availability. Each subnet in your VPC must be associated with a route table, which controls the routing of the subnet. If you don't explicitly associate a subnet with a particular route table, the subnet is implicitly associated with and uses the main route table. A subnet can be associated with only one route table at a time, but you can associate multiple subnets with the same route table. You can create your custom route tables for each subnet to enable granular routing for destination, and as I said, a multi-AZ deployment where you want the route table to use multi-internet gateways in each availability zone. To send non-local traffic through the internet gateway, you must add a route with a destination 0000/0, and the target of the traffic will be the internet gateway ID. You must also make sure that your instances have either public IP or elastic IP address. An elastic IP address is a static and a public IPv4 address that is designed for dynamic cloud computing. You can associate that elastic IP address with any instance or elastic network interface for any VPC in your account. With an elastic IP address, you can mask the failure of an instance by rapidly remapping the addresses to another instances in your VPC. Associating the elastic IP address with the network interface has an advantage over associating it directly with the instances. You can move all of the attributes of the network interface from one instance to another in a single step. To connect your private resources that resides in a private subnet, you need to use a network address translation or a NAT gateway. A NAT gateway enables instances in a private subnet to connect to the internet or to other AWS services. It will also prevent any user from the internet to access those private resources in your private subnet directly. To create a NAT gateway, you must specify a public subnet because the NAT gateway has two interfaces. One interface in the public subnet and the other interface will be placed on the private subnet. You must also specify an elastic IP address to associate it with the NAT gateway. Once you create a NAT gateway, you must update the route table, specifically what we normally refer to as your private route table, to associate the traffic with a target NAT gateway ID for any IP like 0.0.0.0. Instances in your private subnet can communicate with the internet once you have configured the route table. This will give you an outbound connection from your private resources in the private subnet to the internet, but it won't allow any user in the internet to have an inbound communication directly with your private subnet. However, the resources that you have in a public subnet will be able to communicate with your private resources in your private subnet using the target local. Try to think whether we should place the instances in those layers in a public or a private subnet. If you look to data store instances, you must likely put them in a private subnet to add an extra layer of security. For batch processing instances, they are also more suited for a private subnet. Backend instances also for a private subnet, and web application instances most likely they will be used in public or a private subnet depending on your set. If you have a web application running behind a load balancer, then you must put them in private subnet. To understand the Bastion host, consider this scenario. You want to have an access to the EC2 instances that they are resides in the private subnet. In order to achieve that, you can create a Bastion host and you place the Bastion host in a public subnet. So if you want to allow a connection from an external network or from your PC to those Linux instances in a private subnet of your VPC via secure shell or SSH, you can use a Bastion host to mitigate the risk of allowing these external SSH connection to the instances in the private subnet. A Bastion host typically runs on an EC2 instance in a public subnet of your VPC. As you can see in this example, the Linux instances in the private subnet are in a security group that allows SSH access from the security group attached to the Bastion host placed on the public subnet. In this case, Bastion host users connect to the Bastion host so they can connect to the Linux instances. Though you can adopt this architecture to meet your own requirements, the Bastion host should be the only source of SSH traffic to your instances. Now let us look how we can create a virtual private cloud in Amazon VPC.